Good evening, everyone, and welcome to Tour the Night Sky Live with the Royal Observatory Greenwich. My name is Jake Foster. I'm an astronomer at the Royal Observatory, and this evening, as part of National Astronomy Week, we are all going to be doing a lovely little bit of stargazing together tonight. And the best part of it is, you don't need to go outside and get cold. Stay indoors, get cozy, grab some snacks, and join us as we explore the wonders of the night sky this evening. Now, we are live on Facebook and YouTube as well, and we want you to get involved. So leave us a comment, send us a question, and throughout the live stream, we will be reading over those and answering some of your questions as well. Now, this evening, you'll notice I am also in the warm right now, but some of our team are currently out in the chilly cold in a 19th century telescope dome with our modern state-of-the-art telescope, the Andromeda Astrographic Telescope. And that's what we're going to be using this evening as we explore a few different wonderful sights in the night sky. Now, the person operating that telescope tonight is Dr. Greg Brown. And if you're wondering, what is that telescope? How does it work? And how are we going to be bringing the footage from it directly to you? Well, here's Greg to explain more.
This is the telescope that we are going to be using this evening. It's the Andromeda Astrographic Telescope, or AMAT for short, and it's actually a set of different telescopes all on one large robotic mount. It's named after Annie Maunder, born Annie Russell, one of the human computers who worked here at the Royal Observatory around about the turn of the century, the early 1900s. Back then, it was long before the invention of the computer or even the calculator, which means that all observations and calculations had to be done by head and by hand, and Annie Maunder was one of the people to do so. She was also a pioneer of astrophotography, particularly of the sun, and that's why we decided to name this telescope, designed in part to take beautiful images of the night sky, after a pioneer of the field. Now, there are two telescopes on this mount. There is this one, the bigger one, which is the Celestron 14-inch Schmidt-Cassegrain telescope. That's a form of reflecting telescope. So the light enters the end of the telescope, bounces off the back of the mirror, bounces to another mirror right in the front here, and then out through a hole in the center of the first mirror where the image is received by our camera. It's primarily used for planetary imaging and for observing the moon. Basically anything where you want to zoom in to a really, really fine degree and see lots of really small details, this is the telescope. The 14 inches refers to the size of the aperture, the size of the end of the telescope. The bigger your aperture, the more light you're collecting, and so the fainter an object you can see. But more importantly, with the objects we're observing tonight, the larger the aperture, the more detail that you can potentially see, and therefore it's ideal for seeing craters on the moon or the bands around Jupiter. We do also have this telescope here. Now, we're not going to be using this telescope live this evening, but we have been making good use of it over the course of the last few months. It's a Takahashi refracting telescope, a telescope that uses a series of lenses to focus the light instead of a mirror, like the reflecting telescope here. And it's primarily used to look at wider objects, deep sky objects, things like galaxies and nebulae. And a little bit later this evening, you're going to see some of the results of our imaging through that very telescope. Now, on the back of our 14-inch Schmidt-Cassegrain telescope, we have this. This is the camera that we're going to be using to observe the planets and the moon tonight. It's sort of the same as the sort of camera that you've got in your smartphone or in your digital camera at home, but it's designed for astronomical imaging, particularly planetary imaging. It's extremely sensitive, far more sensitive than the cameras that you have at home, and is capable of taking images at an incredibly high frame rate. It can also cool itself down to well below freezing, which is great for reducing the noise when we're taking these images. Now, we won't be able to use, unfortunately, the camera at its highest frame rate this evening. There wouldn't be much point. When we're sending the images to you, they're going to be received at 60 frames per second, so there's no point us running this at well over 100. But nonetheless, we should be able to get some brilliant views of the planets and the moon. Now, this beautiful, historic 100-year-old dome that houses our telescope today used to hold a telescope that was primarily used for observing the sun. But this evening, of course, we're focusing on things better seen during the night, two of the planets and our very own moon. Fingers crossed for clear skies and beautiful views of those objects.
Dr. Greg Brown there showing us the Andromeda Astrographic Telescope. And fingers crossed for clear skies, we're going to find out in just a moment's time. But let's go and find our first target then. So let's begin by taking a look at our map of the night sky this evening, facing towards the south. Now, of course, depending on where you are in the world, you might have a sky that looks a little bit like this. Maybe the stars will be this bright, maybe a little bit fainter. But we are going to begin with an object that can be found even from a bright place like central London, and that is high in the south. It is a bright white dot of light. And in fact, that bright white dot is not a star. It is the largest planet in the solar system. That is the planet Jupiter, and that is where we are going to begin our stargazing this evening. So let's take a look at the Andromeda Astrographic Telescope right now. Live image of it there. Well, it's looking up, so that's a really good sign. And I'm now going to talk to the astronomer operating it, Dr. Greg Brown. So hello, Greg. Are you there?
Hi, Jake. How's things?
Very good, thank you. Greg, tell us, how is the weather up there?
A little chilly, but when it comes to seeing things in the sky, although we've got thin clouds pretty much across the whole of the sky, the good news is that some of our brighter targets are indeed punching their way through, as I believe you can now see.
Whoa, there we go. Look at that. Lovely, the clouds have parted, and look at that. There is the beautiful gas giant Jupiter. So talk us through a little bit of what we're seeing right now, please, Greg.
So you are currently seeing the planet Jupiter. Unfortunately, that great red spot, that beautiful storm on the surface of Jupiter, which I'm sure Jake will be talking about later on, is actually on the other side of the planet. So we're not going to see it today, I'm afraid. We'd need to wait about 5 hours for it to spin around to see it. But we do have these beautiful cloud layers, and we've even got actually 4 of the moons. Now, sorry, 3 of the moons, but I've zoomed in, so we've only got the 2 of them at the moment. I might zoom out a little bit later so you can see the other one. But we've got Io right here, and we've got Europa just over on the right-hand side here. Now, because we're punching through thin cloud, we have had to take the exposure time of our images up a bit. That's why you're probably seeing it at quite a low frame rate. It's only coming through at about 5 frames per second at this point. And that's simply because we need to counteract the fact that a lot of the light is being taken away. So it's a bit more spread out, a bit more fuzzy than I'd like it, but still not doing too badly.
Fantastic stuff, Greg. And people might notice, because I suppose this is proof that this is live footage, things look a little bit wibbly-wobbly right now. What is that wibbly-wobbliness? Why are we seeing that?
Yeah, so the light that's coming from all of the objects in the night sky, the last thing it has to do in that last tiny fraction of a second before it enters your eye is it has to travel through our atmosphere. Now, our atmosphere is constantly shifting around. That's buffeting the light around a little bit like passing light through a prism or through a puddle of water. It's constantly refracting the light, changing its position very slightly. You've probably seen this before. It's the twinkling of the stars. Stars don't twinkle, as strange as that may sound. Actually, the stars themselves don't do that. It's the atmosphere right at the very end. And unfortunately, that's causing everything to wibble about just a little bit.
Fantastic stuff. Thank you very much, Greg. We'll be coming back to you a little bit later on. Now, I'm glad, actually, that Greg mentioned there the twinkling of stars, because you might wonder, when you're looking up at the night sky yourself, why it seems that stars twinkle, but planets don't. Well, we've got here for you a little diagram to show you. It's a little bit crudely drawn because I drew this myself, actually, and I'm no artist. And the reason that stars seem to twinkle is an effect totally of the atmosphere. You see, what's going on essentially here is the fact that even though stars are usually incredibly large, usually even much vaster than planets, they are all, apart from the sun, so incredibly far away that they do just appear as tiny little dots of light. So we can think of the light from them as being sort of just a really thin stream of light. And as it travels through the Earth's atmosphere, it gets battered around by the air molecules, a bit like a cat playing with a ball of string. So by the time it reaches your eye, yes, it does twinkle, it is wibbly wobbly. Whereas, even though the planets look a bit small, they are so much closer to us that we can think of their light more like a wide stream. And while it does get battered around by the air a little bit, it's nowhere near as much, and we get sort of a nice steady stream of light. So that is what we end up seeing. Now, if we look back to that live image of Jupiter there, you can see, of course, it is not twinkling. It is quite a steady stream of light. And one of the features we can see on the surface there are those beautiful bright stripes across the surface of the planet there that we are having pointed out for us there by Greg. Thank you very much. Yes. Now, it's worth noting that Jupiter is a gas giant, meaning it is composed almost entirely out of gas. It is not a solid object like the Earth or like Mars. So what you're seeing are the very top layers of clouds there. And Jupiter spins incredibly fast, about once every 10 hours or so, and it takes the clouds and it stretches them out into long, thin strips that we can see there. And they have particular names as well, in fact. The brown stripes are known as belts, and the white stripes wrote a song called Seven Nation Army. Yeah, no, sorry, couldn't resist. The white stripes are called zones, and they are sort of pulled apart by Jupiter's incredibly fast and powerful jet stream. So that's what we're seeing there. Now, as Greg mentioned earlier as well, we also have some of the Galilean moons beside Jupiter there in the image. So if we take a look at that image nice and large, you can see little white dots. And these are what they are. These are images taken by NASA over various different missions. And as well as that, I've just heard that we have just welcomed into our stream viewers of the official National Astronomy Week live stream. So, hello, welcome to you all. Welcome to Tour the Night Sky Live with the Royal Observatory. My name is Jake, and we are all doing a little bit of stargazing together live here from Greenwich. But what we are looking at here are the four Galilean moons. From left to right, you have got Io, Europa, Ganymede, and Callisto, all rather interesting in their own right as well. Io is the most volcanically active place in the solar system, absolutely filled with volcanoes spewing matter out onto its surface, painting it a lovely mustardy yellow. We've got Europa there, possibly got a global ocean of water under its surface. Beside that, Ganymede, largest moon in the solar system, bigger even than the planet Mercury. And then on the far right-hand side, that is Callisto. Often known as an ugly duckling moon, it is absolutely covered in craters as it gets absolutely pelted by asteroids and other space rocks. Let's go back to the live view of Jupiter there. And as you can see here, we've got a bit of a brightened view of the moons there. You can see they're tiny little dots, but they were first discovered all the way back in the early 1600s by Galileo, hence they are known as the Galilean moons. In fact, the discovery of the Galilean moons was sort of pivotal in first discovering that the Earth is not the center of the universe, that in fact other things orbit around other things other than the Earth. So there we have a beautiful view of Jupiter and its Galilean moons live from the Annie Maunder Astrographic Telescope right here in Greenwich in London. And this goes to show as well that even though we are in the middle of an enormous city, we can still see these beautiful objects, even with a bit of light pollution as well, because Jupiter is so bright, reflecting so much sunlight, it really does just push through that light pollution, so we really don't have to worry about it too much. So, from here, we are going to take a look at our second target of the night. So we're going to continue touring the night sky to look at something a little bit different. So looking at our map of the night sky, we are going to move sort of across to the left and down the sky to find a collection of a few bright stars in a constellation known as Orion the Hunter. And if we zoom in on the stars of Orion here, you can see one of the easiest ways to find Orion is to find three bright stars in an almost perfectly neat line there. Now that is Orion's belt. Beneath Orion's belt, we find in the story Orion's sword, but in that region below Orion's belt, you might see, even with the naked eye, a tiny little fuzzy patch of light. It's clearly not a single star or a planet or a moon. There's something else going on there. In fact, what that object is a vast stellar nursery, a nebula where stars are born. Now, we aren't going to bring you a live view of that nebula because when it comes to these faint deep sky objects, they are incredibly faint. So that does mean that a live view doesn't really look like very much. We really need processed images where hours of footage have been taken, stacked on top of one another to give you the final beautiful picture. And we've got an example of that to show you. It's a NASA image. If you've ever seen a picture of the Orion Nebula, this is probably the one that you've seen. But you can see all these beautiful purples and pinks, these oranges as well. Now that requires hours of light to come into a telescope to then be processed and stacked on top of one another. But what this object is a place where stars are born, an enormous cloud of dust and gas. It is approximately 30 light years wide. Now, that can be hard to sort of conceptualize. A light year is about 10 trillion kilometers worth of distance. It's how far a beam of light travels through the vacuum of space over the course of 1 year. So this object is huge. It's about 300 trillion kilometers wide. To give you a sense of perspective, if the Earth were the size of a grain of sand, the Orion Nebula would still be bigger than the entire solar system. So it is vast, absolutely vast. And it is estimated there are several thousand stars within it, around 700 of which are still being born at this very moment, still being formed. And it's a huge distance away, 1,500 light years of distance, which of course means the light we are seeing as it comes into the telescope, that light has been traveling for 1,500 years. So we are seeing it as it was just over 1,500 years in the past. So we can't bring you much in the way of a live image of the Orion Nebula. As we said, doesn't look like very much. But what we can do is show you a rather nice simulation of what it would be like to fly through the Orion Nebula. This comes courtesy of NASA. So what this nebula is essentially an enormous cloud of gas and dust, because gas and dust is the raw material from which stars are made. There will be tiny little dense clumps within this region that begin to pull in more material. The more mass a little clump has, the stronger a gravitational pull it has. So it pulls in more mass, more gravity, more mass. A snowball effect begins to happen, and then eventually enough pressure builds up and enough heat builds up that that tiny little ball of gas and dust essentially is able to fuse particles together. It becomes a fusion reactor and a star is born. So that is what's happening in that little patch of sky beneath Orion's belt at this very moment. Now, you don't need the Hubble Space Telescope to take a beautiful image like that. In fact, we did take an image of the Orion Nebula from the Royal Observatory just a few weeks ago, and this is the image right here. This is the core of the Orion Nebula, looking towards some very bright stars known as the Trapezium Cluster. And this was taken from the Royal Observatory just a few weeks ago, in fact. Now, you can take beautiful images of the night sky even from a bright city like central London. If that's something that you're interested in doing, then you might be interested in our Introduction to Astrophotography course that we run. It is an online course, which means you can take it from anywhere in the world, and you can learn to take beautiful pictures like this one. In fact, the person who processed this image teaches the course, so the proof is in the pudding right there. If you're interested, you just need to go to rmg.co.uk and search for astronomy courses. So, from here, let's talk about something that's been in the news lately. You may have heard that there is a planetary alignment going on, or, as some are calling it, a planetary parade. But what is it, what's going on, and is it all it's cracked up to be? Well, here's Dr. Greg Brown to explain all.
Terrible news. All of the planets are in a perfect alignment, and their gravity is going to tear the Earth into pieces. Well, no, probably not. You've probably, if you've gone on social media recently, you've heard about the planetary alignment, sometimes referred to as the planetary parade. And you might have even seen it accompanied by a video or an image that looks very much like this. But is this actually what's going on? Well, no, not even close. But we're going to talk about what alignments, conjunctions, and what's actually happening in this video now. This is the imagined, sort of fictitious, perfect planetary alignment. All of the planets in a perfect, dead straight line. And while this is technically possible, it's extraordinarily unlikely. With all of the planets going around the sun in very different amounts of time, they would all have to perfectly in sync come to the same position around the sun at the same time. And that is unbelievably unlikely, to the point that it's entirely possible it will never happen in the entire history of our solar system. But do things like this happen perhaps on a smaller scale? Well, yes. Occasionally we do have planets come to an alignment in the sky. It's referred to as a conjunction. And sometimes they can be pretty close together. You can have planets almost pass one in front of the other. It's tough because the planets in our solar system are not all on a perfect dead flat surface like we've got them here on this table. They're instead slightly inclined to one another, which means the planets will tend to be slightly above or slightly below each other when they pass across each other. But it does occasionally happen, but it's only with 2 or 3 objects. Having all 8 planets in a dead straight line is unbelievably unlikely. So what's happening now? So this is the arrangement of the planets on the 5th of February when we're doing this live stream. Doesn't look anything like a straight line, does it? And that's because the planets are not in conjunction. They're not in a dead straight line. So why are we calling this a planetary parade, an alignment of the planets? Well, it's not a true alignment in that they're not in a dead straight line, but there is something rather interesting happening. Yes, the planets may look like they're sort of all randomly dotted around, and to be clear, the distances between the planets on our model are very, very wrong. But if I put down this line here, this represents the field of view of a person on the Earth who has just seen the sun set. The sun has just dropped below the horizon. And the result is that almost all of the planets are now visible in the sky at the same time. And because the planets, they may not be perfectly on a flat surface like we've got them, they are still roughly aligned with one another in the solar system. That means that they will appear as this great line that goes across the sky. The result is that we've got this parade of planets, 6 of the planets all visible in the sky at the same time, 4 of them visible to the unaided eye. Venus and Jupiter are the brightest. We've got Mars and Saturn, which are also very bright to us. And while they're not visible to the unaided eye, we do also have Uranus and Neptune all in the sky at the same time. The only planets missing are, of course, the Earth, which we're standing on, and Mercury, which is actually hiding over there on the other side of the sun, invisible to us from the Earth at the moment. It's just too close to the sun in the sky for us to see. Even if the planets were all in a dead straight line, there's no way that the gravity between them would be able to affect the Earth. Certainly not to the point of tearing the Earth apart. But with the alignment that we have, such as it is this evening, and will have for the next month or so as the parade of planets continues, there's going to be a fantastic chance to see 6 of the planets in the sky all at the same time. And that's what we've been making use of during our stream this evening.
So there you have it, the Planetary Parade. So if you are just joining us, welcome to Tour the Night Sky with the Royal Observatory Greenwich. My name is Jake, and we are doing a lovely little bit of stargazing together this evening. And so far, the weather has been on our side, and I hope saying that hasn't jinxed it. So from here, we're going to head to our next live target. So let's take a look at the map of the night sky. We're going to move our way up and to the left from Orion to find a bright orange dot nestled in between the twins of the constellation of Gemini. That is the red planet Mars. So let's take a look at the Andromeda Astrographic Telescope, still poised on the night sky, and let's talk once again to the astronomer up there, Dr. Greg Brown. Hello, Greg.
Hi, Jake.
Are you keeping warm? How cold is it up there?
No, it's not too bad, actually.
Good to hear. Well, it's toasty down here, Greg, let me tell you. Probably a little bit too warm.
Oh, fantastic. Thanks for that.
Now, we just saw you there talking about the Planetary Parade, and Mars is, of course, part of that parade. And I was going to say, can we see Mars? And yes, we can.
Which is, to be honest, it was very touch and go. And thankfully, the cloud has become thin enough that we are actually seeing the planet Mars. Now, I know what you're thinking. You're looking at this. It's a blob. It's a slightly orange blob. There is nothing here. Surely this isn't actually a planet. But I assure you, it actually is. What I'm going to do is I'm going to activate something on our software here, which enables me to enhance the view. Basically, take a number of frames, stack them all on top of each other, and then do a little bit of processing live in order to show you a rather better view. And if I actually turn off Show Unprocessed Frames, then what you will now start to see, hopefully, is some of the features of Mars coming through. By far, the most obvious one are these big dark regions. There's one right at the bottom down here. There's another one up here. These are basaltic rock, basically volcanic rock on Mars, darker regions that don't quite have as much of that orange color. But there is one other feature on here which I'm incredibly glad that we have been able to capture, and it's this right at the top here. It's not frozen at all. So this is an actual. We are seeing live views of the thing. So if I turn off Show Unprocessed Frames, then we've actually got this. I assure you is a live view that you're getting here. But what's happening is we're taking a whole series of frames, stacking them on top of each other, and we've got this beautiful bunch at the top here. This is the North Pole of Mars, one of the icy regions, partly water ice, mostly carbon dioxide ice. A brilliant view.
Fantastic stuff. Thank you very much, Greg. Now, just while we are enjoying this view of Mars, and let's continue enjoying this view, we're going to answer a few questions that have come in. A few questions. So, first of all, we have a question from Dan, which is, do astronomers love the moon or find it inconvenient with how bright it is? Well, we're going to be looking at the moon in just a little bit, actually, but it really depends on who you ask. Now, on a clear night with no moon, if we're very lucky, we can see around 3,000 stars. On the night of a full moon, it's more around 300 because the moonlight is so incredibly strong it overpowers a lot of those fainter stars. So it can make it harder to do astronomy, but it really depends on who you ask. Another question's come in from James, age 8. With your telescope, is it possible to see Venus and its pancake domes? James has been reading about volcanoes on Venus. Well, first of all, that's great to hear, James. Great stuff. Well, it's a really good question. Now, unfortunately, we wouldn't be able to see any features on the surface of Venus, and the reason for that is because Venus is pretty much always covered in a thick layer of cloud. It's got very thick, sandy-colored cloud, so unfortunately, we would need radar images to punch through that cloud to see more. But thank you for that question. We'll answer one more as we continue to look at the red planet here. Let's see. So many lovely questions. Yes, well, when you move the telescope, do you actually have to move and focus it by hand, or is it controlled by computers? Well, actually, I'll send that question right back to Greg. Are you there, Greg?
I am indeed.
So when we move the telescope, do we move it and focus it by hand, or is it controlled by computers?
For the most part, it's all controlled by computers. So we've got a whole bank of monitors, which I'm currently looking at, one of which is sending the image that you're seeing to you. But the rest are controlling the telescope, pointing it where I want it to go, focusing the telescope, doing all sorts of other things that are necessary in order to give you the best view we can.
Excellent stuff. Thank you very much, Greg, and we'll talk to you again in just a little bit. And thank you all for those questions. Keep them coming in. So, one last thing about Mars we'd like to point out, of course, is that beautiful orangey color. And that is because the surface of Mars is covered in a substance known as iron oxide. And we've got a few images from the surface of Mars taken by various missions from various space agencies. Well, in particular, NASA and the European Space Agency. And the truth is that this iron oxide is rust. It's rust, that very same material that might gather on an old bicycle left out in the rain too long, covers the surface of Mars and paints it that orangey color. But make no mistake, while it may look like a desert, it is not warm. The surface of Mars has an average temperature of minus 60 degrees Celsius. It is freezing cold and icy cold desert. So not maybe a place you'd want to go on holiday, but could human beings visit it in theory in the future? It is very much possible and something that space agencies are looking to do in the future. Now from here, we are going to move on to another target. And now for something completely different. Can't get much more different from a planet when we head to our next destination. So looking at the map of the night sky, we are going to move from Mars, from that red dot, all the way across the sky. And this one's going to be a more difficult one to find if you're doing this yourself later tonight or on another date. A bit of advice is to look for a constellation of 5 bright stars in the shape of a W, the letter W. And in fact, you might notice that one of the dips in that W is a bit wide or a bit pointier than the other. Now that pointy bit is going to act as an arrow. It points us across the sky to a little fuzzy blob. If you've got incredibly dark skies, you might be able to see that with the naked eye, but more likely you'd need a pair of binoculars. That little blob of light just so happens to be the core of our next closest galaxy, the Andromeda galaxy. And this object is vast. It is by far the biggest object that we're going to be taking a look at this evening. And in fact, we have an image of the Andromeda galaxy that was taken by the Andromeda Astrographic Telescope not too long ago, only in the past few weeks. And once again, the reason why we're showing you an image rather than a live feed is because this is a faint deep sky object. It doesn't look like much as a live feed. What this is a few hours worth of footage stacked together on top of one another to form the final image. And what is it we are actually seeing here? Well, the Andromeda galaxy is an enormous collection of approximately 1 trillion stars. It is vast, about twice the size of our own Milky Way galaxy in which we live. Andromeda is about 2.5 million light years away, which means it takes the light that comes from it 2.5 million years to get to the Earth. So, just like any other object in space, the further away it is, the further back in time we're actually seeing it. So we're seeing it not as it is now, but as it was about 2.5 million years in the past. So that is what we're seeing there, and it just so happens, you might see at the bottom there, a rather worrying statement. It gets 70 miles closer every second, and that is completely factual. The Andromeda galaxy is actually coming for us, or towards us. It gets 70 miles closer every second. So right now, it's 70 miles closer, and again, and again. Sounds quite worrying, but because it is so incredibly far away, it won't hit us for another 4.5 to 5 billion years. It will hit us, but not for a very long time. And as we are very cheery here, we'd like to show you a visualization or a simulation of what that's going to look like when the Andromeda galaxy hits us. So we're going to do a bit of a play-by-play here. There is the Andromeda galaxy. Oh no, wait, that's us. That's the Milky Way galaxy. Apologies. Galaxies do tend to look quite similar. The Milky Way galaxy, containing anywhere between 200 and 400 billion stars at the best estimate. It's quite hard to tell how many stars are in a galaxy when you're actually inside of it. But in about 4.5 billion years, our galaxies will meet for the very first time. Our mutual gravitational attraction inevitably brings us together. There is a glancing blow, throwing a few billion stars out into the intergalactic void. You can see here as well, the Triangulum galaxy gets a little bit involved here. It is orbiting around Andromeda, so it is along for the ride. Over the course of another few billion years, our two galaxies inevitably begin to merge together, the supermassive black holes at their centers rapidly orbiting around one another, possibly creating ripples in the fabric of space itself, a phenomenon known as gravitational waves. Until eventually, about 7.5 billion years into the future, things begin to settle down and a new galaxy arrives. I mean, who knows what we'll call that galaxy? Milkdromeda has been suggested, but we've got quite a long time to figure out what we would like to name it, because I don't like that one very much. But the good news is, if anything is still around, if the Earth is still around 7 billion years in the future, when it comes to these galaxies colliding, there's very few actual head-on collisions between stars. So there's a very good chance that the solar system, in whatever form it'll be in 7 billion years, will remain intact. So there we go. But yes, these deep faint sky objects like galaxies, like nebulae, they're very difficult to see because of how faint they are. So we do need to take those images. But if Andromeda was really bright, if it was so much brighter than it is now, what would it actually look like in the night sky? Well, we have an image to show you how big it would actually be in the night sky if it were as bright as we would like it to be. Look at it. It's about 6 times wider than the full moon in the night sky. It is just so faint that our eyes cannot see that. And that is why we need to take these long exposure images. But there we are. Now, there are lots of beautiful images of the Andromeda galaxy, but not all of them are award-winning. And every year at the Royal Observatory Greenwich, we run the Astronomy Photographer of the Year competition, where the very best astrophotographers and people who are just starting in astrophotography get to compete to see whose images are voted the very best. So what goes into an award-winning image of the Andromeda galaxy? Well, take a look at this.
Donc, Xavier et moi, nous sommes français. Il y a environ 4 heures de route entre nos deux maisons. Et Marcel est allemand, et il y a environ 12 heures de train entre chez lui et chez nous. On a l'habitude de travailler à distance, mais aujourd'hui c'est spécial parce que c'est la première fois que Marcel vient chez moi et c'est la première fois qu'on se rencontre. Donc l'année dernière, Xav et Marcel ont découvert une potentielle nébuleuse planétaire. On est en contact pour la shooter. Et cette expérience de découverte, de recherche, m'a donné envie d'expérimenter. C'est ce que j'ai fait sur M31. Et donc je leur ai envoyé les fichiers d'expérimentation que j'avais fait. Et c'est là où ils ont aperçu l'arc et que l'aventure a commencé.
In the image Andromeda Unexpected, you see the bright galaxy M31 and a little bit unexpected, a gigantic blue arc of ionized oxygen gas, never seen before. It changes the face of the Andromeda galaxy forever.
Faire une découverte, c'était une sensation incroyable. Et pouvoir nommer cet objet pour l'éternité, finalement, c'est un aboutissement pour un astronome amateur.
Imagine the Andromeda galaxy is the most photographed cosmic object for over 100 years, and making such a discovery in the vicinity of the Andromeda galaxy showed us that even amateurs can make great discoveries.
Il n'y a pas un meilleur souvenir, il y en a plein, notamment travailler avec des gens que je ne connaissais pas ou des amis pour aller shooter avec eux. Les principaux challenges, ça a été donc d'acquérir 110 heures de pause avec une météo parfois compliquée. On a dû faire 5000 km pour pouvoir shooter. Le traitement a été aussi long et tout le travail de recherche, le pilotage d'une équipe qui parle des langues différentes avec les professeurs. Mais tous ensemble, on a réussi à transformer le challenge en une belle découverte.
Our team is French, is German, and we had team members from the United States, especially Professor Robert Fiesen from the Dartmouth College in New Hampshire. It's been a wonderful collaborative experience.
Qu'est-ce qu'on peut apprendre sur nous-mêmes grâce à l'astronomie? Ça permet de se remettre à notre place, notre vraie place d'être humain, sur une petite planète au milieu de l'univers. Il n'y a pas besoin de faire des découvertes pour ça.
Andromeda, unexpected, winner of the Astronomy Photographer of the Year competition a few years ago. If you'd be interested in seeing more beautiful images of the night sky, this year's Astronomy Photographer of the Year exhibition is currently able to, well, you're able to come and visit it. It's at the National Maritime Museum and it's completely free to visit. So do book yourself a free ticket and come along to see some of those beautiful images. Now, if you are just joining us for the first time, welcome to Tour the Night Sky with the Royal Observatory Greenwich. My name is Jake, and we have been doing a lovely little bit of stargazing together this evening, and we have one more target left to go. So let's take a look at our map of the night sky for the last time this evening, and our fifth and final target. You really don't need directions to find this one. It is undoubtedly the brightest object in the night sky this evening. It is, of course, the moon. Unmissable, big and bright. So let's go across to the Andromeda Astrographic Telescope up at the Royal Observatory Greenwich, still pointed up, so that's a good sign. And let's talk once again to Dr. Greg Brown. Hello, Greg.
Hello, Jake.
How are things?
Very good, I'm glad to hear, glad to say, rather.
Very good.
Go over to the view of our telescope. Yes, we have indeed managed to, without too much difficulty, I should say, find the moon, and it is more than punching through the clouds. So we've done pretty well this evening.
Incredible look at this, and yes, only a minor bit of wibbly wobbliness, so the seeing is quite good. The quality is lovely stuff. So which part of the moon are we looking at right now?
We are looking at the more of the northern part of the moon. We are looking at the boundary between a couple of the different dark regions on the moon. So right down at the bottom here, this is Mare Tranquillitatis, or the Sea of Tranquility. And then as we go further up in this sort of direction, you're heading towards the Mare Nectaris, or the Sea of Nectar is up there.
Wonderful stuff, beautiful. And what type of cheese is that, Greg?
Probably Wensleydale, I'm thinking.
You heard it here first, folks. Well, second, I suppose. Excellent stuff. Now, from here, there are lots of beautiful things to point out on the moon, of course. First of all, those wonderful craters. Now, space rocks, asteroids smash into the moon relatively regularly. And the thing about the moon is it doesn't have any discernible atmosphere. Here on the Earth, there are space rocks that come crashing down to Earth. But the thing is, we have an atmosphere. A lot of them burn up in that. And we have a lot of ocean as well. So most of the space rocks that come to Earth, and it's about 50 tons a day, most of that goes actually into the ocean. But on the moon, there's no ocean and there's no atmosphere. So anything that's trying to hit the moon will hit the moon, and it will probably leave a mark. So we can see all of those craters, many, many, many of them, some of them a few kilometers, some of them tens of kilometers wide, a few of them as well, hundreds of kilometers wide. They are vast. And in fact, in this footage we can see right here, this live footage of the moon, you can see in the middle of quite a few of these craters, there are these little bumps that you can see. Those are mountains. Yeah. Some of them a few kilometers tall. There are entire mountains inside of these craters, so it really is quite an incredible thing. Now, as well as that, Greg pointed out, we are looking at some of the maria. These are the dried up volcanic lava beds, essentially, molten lava that used to flow across the surface of the moon several billion years ago before drying up, leaving these dark patches behind. And it really is lovely to see it this evening, live from the Royal Observatory Greenwich. Now, just while we're enjoying this view of the moon, and let's get this view nice and large so that you can all see it as well, I'm just going to answer a few more questions that have come in. First of all, can you say hello to Jackson, if at all possible? He's 4 years old. Yes, of course we can. Hello, Jackson. Good evening. Thank you so much for joining us. More questions coming in. Is there a way to overcome weather conditions and see through cloud cover, or do you just have to wait for a clear night? Unfortunately, for optical telescopes, those making use of visible light, so the ones that we're used to, unfortunately there is still no cure for clouds. If clouds are capable of blocking light, which they are, the light can't reach the telescope, and therefore we can't see anything. What would fix that problem is a radio telescope. But those are essentially enormous satellite dishes, and you don't really get an image from them in the same way instantly. So, unfortunately, for now, well, forever technically, by the laws of physics, we cannot punch through the clouds with regular telescopes. More questions coming in, which is lovely to see. Thank you so much, everyone, for tuning in and sending in these questions. Let's see. Oh yeah, why is Pluto no longer a planet? Now, that's a good question. Well, when it was discovered in 1930, Pluto was the 9th planet of the solar system. But in 2006, 76 years later, more and more objects like Pluto were being discovered. Objects like Ceres, Eris, Makemake, Haumea. Great names, great objects, but more and more things a bit like Pluto. So a decision had to be made. Do we have 20, 30 planets in the solar system, or do we change the rules a little bit? So nowadays, planets follow 3 rules. Rule number 1, be round. But Pluto is quite round. Rule number 2, orbit the sun. But Pluto does that as well. Rule number 3 catches Pluto out, and that is to clear your neighborhood. That means don't be surrounded by asteroids and space rocks. Don't have all of that stuff in your way. And certainly don't cross over the path of another planet. And Pluto does that. So unfortunately, Pluto, no longer a planet. But that doesn't mean it's any less important or any less interesting of a place. So a beautiful view of the moon here. I'm going to talk to Greg once again. Hello, Greg. How you doing?
Hello.
Would it be possible for us to get a little view of the South Pole of the moon? Is that possible?
But just before we do that, I thought you might want to note this point right here. So the reason I chose this particular place is that right where my mouse cursor is, that is where Apollo 11 landed on the surface of the moon. So that is Tranquility Base. Now, it's far too small for our telescope to see, but nonetheless, it is in that area.
Aha.
Okay.
Incredible stuff. Well, keep it there for a moment. You're absolutely right. There is Tranquility Base, and as Greg says there, it is not possible for us to see that equipment. It is far too small. In fact, no Earth-based telescope is powerful enough to see the landing site there. Not even the Hubble Space Telescope is capable of seeing it, but many objects that have been sent to orbit the moon, robotic spacecraft, have photographed it since. But brilliant stuff. Thank you so much, Greg. It was right there, and of course I didn't see it because we cannot see it. Excellent stuff. So we're working our way up to the South Pole, and even though it looks like we're moving up, the image is inverted. So it looks like we're heading up to the North Pole, but we're actually heading down to the South Pole. Now, you can see here, first of all, beautiful craters here, and in fact, we're seeing the transition from daytime on the moon to nighttime. That little area along there, the transition between day and night that Greg is pointing out for us there, that is known as the terminator. And that is a great place to observe the moon because you get a lot shallower angles of sunlight. So you can see the craters have beautiful shadows forming along them. So it makes them a lot easier to see. But the reason we're pointed at the South Pole is because it's quite an exciting place, actually. Evidence now suggests that perhaps in some of those craters there could be deposits of ice, frozen water, H2O. And the reason it can be there is because some of those craters are really deep and haven't received any direct sunlight, perhaps in billions of years. So the ice never melts away. That's really exciting for astronauts because, well, frozen water, H2O, is an incredible resource. First of all, it could be purified and then used as drinking water for astronauts, but also at the same time, you could take it and separate it. H2O separates into H2 and O. You've got hydrogen, that's rocket fuel, and you've got oxygen that you can breathe. So it's an incredible place, the lunar South Pole, and an exciting place because that could be the fuel for the space travel of the future. Thank you so much, Greg. I mean, what an incredible view and what luck we've had this evening. Now,
Absolutely.
one final question I'll leave you with, Greg, a question that's come in as well, is that for anyone who's interested in getting involved with stargazing and they don't know where to begin, what tips would you give them if they're feeling inspired after tonight?
Tonight we've been using some pretty advanced technology, some pretty big telescopes in order to observe the night sky. But the reality is you don't need any of that. You can start with just your eyes. The Moon, Jupiter, and Mars are all visible to the unaided eye, as are Saturn and Venus. So definitely worth having a look just with your own eyes to begin with. If you want to start taking that first step into actually looking closer into the sky, but don't really want to fork out for a telescope just yet, consider a pair of binoculars. You'd be surprised how much better a view you get of the night sky, and there are even a handful of objects in the sky that are often better seen with binoculars than they are with a telescope that tends to zoom in far too much, like the Pleiades, a cluster of stars visible in the night sky at the moment.
Excellent. Thank you so much, Greg. And to as well Robert and Dan, who are up there with you in the cold as we observe this evening. And what a beautiful image to end on, the south pole of the moon, pointing us towards beautiful resources of frozen water, perhaps for future astronauts and future missions out into space. And with that, we have reached the end of our show. So thank you so much for tuning in. Thank you for these amazing questions and comments. We really do appreciate it. Leave us a like if you liked it. Subscribe if you'd like to see more stuff like this. And I'd like to say a huge thank you to our team here at the Royal Museums Greenwich, everyone who helped us to put this all together. And we wish you all a very happy National Astronomy Week. And we wish you all clear skies. Thank you and good night.